Himalayas to come into existence. So the present day area of northern Uttar Pradesh, northern Bihar, the portion of North Bengal, Assam, even Uttarakhand, all of these will be covered by the fourth range of Himalayas, which will emerge in, again, let me again clarify, because I do remember mentioning it once in the session, and one of the candidates, they panicked that recently I bought a piece of land in northern Uttar Pradesh, and you are saying that fourth range of Himalayas is going to come there, so my money is wasted. So let me clarify here that this fourth range of Himalayas, the process of formation in itself is going to take around 10 to 15 million years from the present. Okay, so 10 to 15 million years in the future, you are going to experience the fourth range of the Himalayas. And that is why nowadays you'll find frequent volcanic or frequent earthquake activities happening across this region and this region. Okay, so this is basically about the process of formation of the Himalayas. Very quickly, I will give you the recap of the entire process again, even though this is a kind of a detailing that you don't find in any kind of a book in this kind of a schematic representation. So I would encourage you to study from this particular PPT itself and try to recollect on your own with the help of images, diagrams, anything that you can. Try to recreate it on your own. Okay, so here, when we talk about the formation of the Himalayas, initially you had a stage where the Indian plate separated from Gondwana land and started moving north with a great speed. Now, as it moved towards the Eurasian plate, there was a Tethys Sea which lied in between. Now, slowly and steadily, as the Indian plate continued its march to the present position or continued its movement to the north, the Tethyan sea floor underwent subduction. And that subduction that it underwent happened across both the region of the Eurasian plate as well as the Indian plate, leading to volcanic events and volcanic eruptions across the margin of both of these plates. That is why, still in the region of the Himalayas, you will find many evidences both on the side of the Eurasian plate as well as on the side of the Indian plate. You'll find evidences of a lot of igneous rocks to be present there as well. Now, as this convergence happened, you had a situation where the rate of movement of the Indian plate was much more faster as compared to the rate by which the Tethyan seafloor could undergo subduction. Indian plate was pushing it at a much faster rate. So the Tethyan seafloor, because it could not subduct at the same rate, what would happen? The Tethyan seafloor started getting folded upwards and it was lifted up. So that is what is referred to as the closing of the Tethys or the upliftment of the Tethyan seafloor. After that, you had the continental convergence, that is the fourth stage. Continental convergence happened, and that convergence was a pure convergence of continents between the Indian and the Eurasian plate. That is when the folds started getting created. But as this compression started happening, you had a kind of a limitation in terms of how much deformity can the rocks experience. So the rocks beyond a particular point could not withstand that huge amount of deformity or deformation. So that is where these rocks significantly, as they were getting compressed quite significantly, these rocks broke at the point where the stress was being applied. So that is where you had development of cracks. And then further compression meant that not only the height continued to increase, it became narrower as well, the existing range, but also there was an upliftment here as well. So formation of the second range happened. All the meanwhile, the existing range kept on getting higher because of continued compression. This process continued, and that is when you had development of further cracks, formation of shivalics, and now another crack has appeared in front of the shivalics, indicating the formation or the folding of the fourth range. All the meanwhile, as the compression still continues even today, the Indian plate is pushing towards the Eurasian plate at a speed of 1 to 2 centimeter per year even today. So even today, the height of the entirety of the Himalayas continues to increase, and that region continues to be a hotbed of seismic activities or earthquake events. Okay, so that is something that is about formation of Himalayas, which should suffice even for your optional preparation. This is something which should be more than sufficient. Okay. Now, then here Tethys seafloor got uplifted. This is a motion which is ongoing, and this is the reason for the Himalayas rising height. And there, at the margin, at the boundary of these plates, you have very frequent volcanic, or rather earthquakes, seismic activities, and there is a substantial instability that the plates have. Okay. So I would urge all of you, the portion that you have covered, let me assure you, with this kind of a schematic, you won't find it present or available in any kind of book. You are free to explore. So I would suggest to you that use these images, draw it on your own, try to recreate a kind of a story on your own, that how this happened. That will not only improve your writing skill, would also help the conceptual clarity, because once you start writing, that is when you realize, okay, these portions were not very clear. So try to write it on your own, try to apply logic in each of these stages, and that is something which is going to entrench not only the portion of plate tectonics, but also the entirety of the northern part of Indian geography quite significantly. We will revisit it again in the portion of Indian geography about the features of these cracks. These are referred to as thrust faults. What are the names of these thrust faults? We will be referring to that again in the portion of Indian geography. But please don't let go of this advantage. Okay? Do capitalize on that. Now, Gaurav, PYQs. Gaurav, I think it is the 15th or the 20th time that you are asking for the PYQs, isn't it? PYQs, my dear friend, we have not covered a substantial portion. So there are two reasons why people always they keep on requesting for PYQs. And I hope this is taken in a good manner. It is not taken in an offensive manner. One of the reason is that you already know the answers of the PYQs to be discussed, and you want to be one of those guys who marks it all correctly and emerge victorious at the end. The other reason is you get that kind of a rush of having that poll and the PYQ. So trust me, I will discuss all the PYQs. Please don't seek the excitement of that. As of now, I want you to invest all your attention in understanding the plate movements. If you are very comfortable with the portion which is being taught, just try to think about it as a portion of revision. Wherever it is essential, wherever it is required, I will be discussing the PYQs. I will give you your KBC moment in your life, or the Kaun Banega Crorepati moment in your life, where you are supposed to click on that option. And then eventually I will get the request that show us the leaderboard to see if I am on the top or not in these case of PYQs. I will give that moment in your life. But as of now, please pay attention on this particular portion. I hope it is clear. Okay. Now, where is it that the water of the Tethys Sea went? Because that portion of, or that entire process was so very slow, that it is something which happened over a period of millions of years. That water slowly and steadily exited from the site. Significant portion of the present day Rajasthan that you have, where you have very rich oil reserves and rich amount of limestone, significant amount of that portion was underwater as the Tethyan sea water was pushed to the sides. Okay, so in fact, I will give you the map location for map pointing locations today as well. You will find that to the east of Mediterranean Sea you have the Aegean Sea. So Aegean Sea is considered to be a true remnant of the ancient Tethys Sea. So, and Mediterranean, also significant portion of it is also supposed to be a remnant. Now we come to the portion of the divergent plate boundaries. By the way, what is the time period when this happened? So the creation of the first one, the creation of this first fold, is supposed to have happened close to around 60 to 55 million years back. The second fold was initiated close to around 40 million years back. And then the third fold, that is the newest, that is the Shivalik, that upliftment started happening around 10 to 15 million years back. So that is how young the Himalayas are. Now, when we talk about the convergence of plates, the convergent plates in general, here we will agree, I hope you will agree with me, that some portion of the existing plate gets destroyed in the process, isn't it? Some portion of the subducting plate during the convergence it gets destroyed, it gets consumed in the lower portion of the planet. So that is why the convergent plate boundaries, these are also referred to as the destructive plate margins. Why? Because significant portion gets subducted, gets consumed. Okay. Now, after this, we come to the portion of the other plate, that is the divergent plate boundary. Now, divergent plate boundary means they are moving away from each other. Why are they moving away from each other? Because of convection current initiated underneath, right? Due to convection current present underneath. PYQs will enhance knowledge as well, as I am a beginner, as I'm worried about geography. Guys, please have that much amount of trust that I won't leave you high handed in certain topics, that these topics are not even covered. I will cover the PYQs, but more than the PYQs, as of now, I want you to pay attention in understanding the concept ones. I will discuss the PYQs. Where will the PY, they have been included in the PPTs itself. So where will we escape other than the PYQs? So don't worry about that. And also understand, till now we have not covered a substantial portion. We are going very, very slow. We have not covered a substantial portion. That chunk of PYQs will be there for discussion. So you have a limitation in that as well. I cannot conjure up a new PYQ up in the air and then throw it on the paper. So have some patience, have some trust. We will cover all of these areas. Don't worry about that. Okay. Now, whenever you have divergent plate boundary, the existing plates, they are pushed aside and newer crust is created in between. So that is where it is also referred to as a constructive plate margin. Why? Because there is always going to be creation of a newer crust in between. As the existing ones, they will move away, a newer crust will replace them. So construction of a newer crust, that is constructive plate margin. Now, this divergence can happen underwater, as we have seen in the case of mid-oceanic ridge. It can happen in the case of the land areas as well. So when it happens in the case of the land areas, we have seen that initially the land starts thinning. It is getting stretched. The land starts thinning. There is a creation of a depression of sorts. That is what we refer to as a rift valley structure. So overall, the landforms that are created generally underneath the water bodies, you will observe that whenever there is a divergence, there is a kind of a ridge-like, mid-oceanic ridge-like feature created. Over land areas, there is this divergence. Okay, observe the crack. Now, just to give you an idea about the size of the cracks, all these small structures that you see on the side of this large lake, these are very large 3-story, 4-story buildings that you are talking about. So you can imagine how large this crack is. This is what is a rift valley. Rift is what? Rift means a kind of a tension. Valley is a narrow feature. So a narrow feature, a narrow valley-like feature created due to the tensional force, that is a rift valley. This is the image of the East African Rift Valley. Okay, where the continent of Africa is getting divided into two different portions as we speak. Now, let me ask you another question. Now, you have seen that large cracks develop. In the case of these mid-oceanic ridges as well, large cracks develop. So when you will observe volcanic eruptions in these cases, what do you think will happen? Will the volcanoes always be concentrated from a smaller area? Or do you think there can be a scenario where a large crack opens up and molten materials, they start emerging all through the cracks? What do you think? Can the volcanic eruption happen like that? Very good. Yes. So this is the kind of eruption of volcanoes which are frequented, where you will observe very large cracks which open up. And across those large cracks, molten materials, they start spreading out. This is what is also referred to as a fissure volcano. Fissure means what? Fissure represents crack. So that is what is observed in many of these divergences. So here, take the case of the mid-oceanic ridges. Observe here the mid-Atlantic ridge. Okay. This is your mid-Atlantic ridge. By the way, the greatest rate of divergence as of now across the planet, anywhere where it is happening, is across this region between the Pacific and the Nazca Plate. This is what is also referred to as the East Pacific Ridge or the Chilean Ridge or the East Pacific Rise. It is where the rate of divergence currently experienced is close to around 15 centimeter per year. That is the rate of divergence which is happening. Now, in many of these areas, these frequent volcanic activities end up piling up material so much that they can create island-like features as well. So sometimes these volcanic activities happening in the mid-oceanic region, they can end up piling up the materials, creating an island structure. In fact, the creation of Iceland in itself is attributable to this mid-oceanic ridge. This is the reason why Iceland experiences very frequent volcanic activities. Every year, you experience volcanic activities rocking the region of Iceland. So here you have the North American plate, here you have the Eurasian plate. In between them, you have the mid-Atlantic ridge. Okay. And that is where you have the island of Iceland getting created. So islands can also get created. An example you can give of Iceland. Okay. So when we talk about landforms, islands. Example, Iceland. Okay. So this is about the constructive plate margin or the divergence of plates. Then we come across the transform movement of plates or transform plate boundaries. Now, transform plates movement means they are moving parallel to each other. Now, when they are moving parallel to each other, will there be a creation of a newer crust? No. Will there be a destruction of the existing crust? No. So, in this case, neither a new crust is getting created, nor is an existent crust getting destroyed. So, that is why these are also what are referred to as conservative plate margins. Okay. Conservative plate margins, that is what they are referred to as. Now here, when the plates are moving against each other, rubbing against each other, they will experience a lot of resistance with respect to each other, huge amount of resistance. So what will happen? There will be development of very deep and large cracks. Very deep and large cracks will develop. And that movement will also not be smooth. So that movement, basically, as it keeps on happening, think about it, put your own fingers here or put your own palms at place and observe that as they would be moving, there would be resistance Suddenly there would be a sudden motion. So very massive earthquakes. Very massive earthquakes. By the way, even in the case of divergent plates, when the plates are trying to move away from each other, there also you experience earthquakes. But because the plates are already moving away, there is not that much factor of resistance involved. So that is why the earthquakes observed across the divergent plates, they are slightly moderate in terms of their category, in terms of their magnitude that they have. Whereas across convergent plates and transform plates, the earthquakes which occur, they are very, very strong. Okay, so that is the difference. And why they are very strong? Because in the case of convergence, in the case of transform, in both these cases, you have the plates experiencing resistance, overcoming that resistance. And when they do overcome that resistance, immense amount of energy will be produced. So these cracks, they get created. So plates move parallel to each other, neither creating nor destroying a feature, leads to significant tension being built up and creation of earthquakes and faults. Example, yes, Lakshmi, that is also correct. Here you also have the San Andreas fault, California. So that is why San Andreas Fault in California is the one which is very frequently, or it is that area where very frequently people experience massive earthquakes. And even nowadays, also from now, also, if you start following current affairs, you will observe that in 1 year, you will come across few incidents of minor or major earthquakes striking the region of California. Okay. So these are your the aspects of various different plate movements. These are your major plates. This is the depiction of the plates along with their respective movements that you can associate with. Okay. Now, I hope faults mean a large crack where there is a respective movement. So there are joints, cracks, and faults. So when we talk about any fault, that means we will study about faults in the next chapter. So faults basically mean whenever there is a large crack and there is a respective movement of land with relative to each other. Okay. Trenches are the deep depressions that you find in the case of the ocean floor. That you find whenever you have the oceanic convergence happening, there is a creation of a trench. Why Iceland experiences volcanic activity? Because it is on top of the mid-Atlantic ridge, and mid-oceanic ridges, they experience volcanism. Okay. Is it fracture? It is a kind of a fracture, but it is not quite prominent one. Okay. What was the cause of the rate of the Indian plate movement at such a high speed? Again, convection current underneath the Gondwana land that continued to push. And there were other events as well. You had the Reunion Islands erupting at that point of time, also creating that uh, kind of an effect. What is the reason for Turkey earthquake? So, Turkey earthquake overall, if you take a look at it, this has been initiated because of the African plate, the minor Anatolian plate which is present, and the Arabian plate, and also the Eurasian plate. So Eurasian, Anatolian, and Arabian plate, when they will move, that will end up creating massive earthquakes. Now here, observe this region as well. So this region, that is the region of Gujarat. It is understood why Himalayas experience so high frequency of earthquakes. But Gujarat also experiences very severe earthquakes. And why is that? Because if you take a look at Gujarat, it is at the boundary of three plates: Indian plate, Eurasian plate, and the Arabian plate. That is why Gujarat, any movement which is experienced in any of these plates, Gujarat experiences earthquakes. Okay? Now, then we move ahead with certain PYQs finally, so that you can take a sigh of relief in this case. So here, why Tethyan seafloor could not get submerged completely? Because the rate of movement of the Indian plate was much faster than the rate at which the Tethyan seafloor could submerge itself. Is Indian plate still moving at a speed of 15? No, it is now moving at a speed of around 1 to 2 centimeter per year. What is between the inner crust and the outer mantle? You have the Moho discontinuity. Aravali is also a fold mountain. Yes, Anurag. Okay. Will Indian plate keep on moving always? It depends. Once the convection current stops, it will stop. Okay. We have webinar also. Please do it fast. So in the case of Hari, you are free to leave at a point of time around 8:30. I won't be teaching any content after 8:30. So here the question is, which of the following phenomena might have influenced the evolution of organisms? Continental drift, glacial cycles. Which of them influence the evolution of organisms? So the animals and the beings living in those areas, organisms living in those areas, they would have adapted to those changes and would have evolved accordingly. Similarly, when we talk about glacial cycles, we talk about the frequently occurring ice ages and then again normal warming conditions. So that is where, as the temperature continues to change, the organisms also evolve. So here the answer is going to be C, that is both 1 and 2. Then, which of the following pairs is which has been marked is incorrect, but then majority on looking at your name in leaderboard, you'll be disappointed now because the correct answer was marked incorrectly here. So continental drift was provided by Alfred Wagner. Expansion of universe was provided by Edwin Hubble. Photoelectric effect was provided by Albert Einstein. So this is basically about the various theories. Then, in the structure of planet Earth, below the mantle, the core is mainly made up of which of the following? Sandeep, if there are so many eruptions under the sea, then kilometers is iron. So here, the core is made up of iron and nickel. So that brings us to the end of this particular chapter. And now let us take certain questions, and then all those who want to leave the session, now no more content will be taught, you can leave the session. So, Sakshi, how to read Atlas? Is there any technique? I don't find some regions in Baiju's Atlas. Which is the region that you are unable to find, my dear friend?